Hello and hello everyone. This is Nirmal Raj working as an assistant professor in Department of Civil Engineering in Mahalingam College of Engineering and Technology, Pollachi. And along with me, one more faculty is there. His name is Mr. Praveen Kumar. He is also working as assistant professor in the same stream, in the same college. And I welcome everyone for this flipped classroom activity video. And students, those who are watching this video, we will be mainly focusing on this video about basic design concepts in design of RC elements. So before getting into the topic, so you will see what is an RC element. In civil engineering, most of the structures we see is often constructed by means of concretes. So to give more strength in the concrete, so we'll be embedding the reinforcement in the concrete so that the concrete can take more tension loads. So such type of structures are called as RC structures. In that, it will be having so many elements like beams, columns, slabs, footings. So in that we will be seeing what are the basic concepts behind the design of RC elements in this video. Okay, so let's get into that topic. So basic design concepts. So if you see, the reinforced concrete members are basically designed based on the codal provisions. In that we'll be having two methods. The first is like we'll be doing the designs based on theoretical calculations. So such calculations is mostly seen for commonly used buildings like office buildings, residential buildings, and some institutional buildings. So whatever the conventional buildings we are having it, for that we'll be using the theoretical calculation procedures. And then the other method is experimental investigations. So when we like to have some special structures which is unique and which is not similar as we already having it, so we'll be going for some new concepts, or based on the research results, we'll be doing some analytical works, and based on that we'll be going for some new concepts, utilization of new concepts for the design of new buildings. So that will comes under experimental investigation. So example for an experimental investigation is Melayu viaduct. Okay, so this is the two methods in basic design concepts. So one is theoretical calculations, the other one is experimental investigations. If you have conventional type of buildings, go with theoretical calculations. If your structure is very unique, or it will be very new, then go with experimental investigations. Okay. If you see the experimental investigations, so it can be done in the laboratories as we know it. So how we usually used to do is, in case of any new structures, we used to make it as we need to scale down the structure dimensions to a models, and we have to fabricate the model, and we have to test the model in the laboratory with the equipments. Equipments will be having many equipments as such, so we have to stick with the appropriate equipment to test the strength of the material, and then we can see how the actually model is giving the response. Based on the model response, we can extrapolate to the actual structure. So based on that, we can suggest that okay, the design what we did for the new structure is holds good. Okay, so the other method is theoretical method. It consists of numerical calculations based on procedures prescribed in the codes. So based on several researches conducted, so the Bureau of Indian Standard has given us some standard procedures which is called as codal provisions for us to design the different type of structures. So for concrete design structures, so we'll be referring Indian Standard number 456 version 2, year of publication is 2000. IS 456 2000 we'll be using it. So in that code of provisions, the code of provision is actually based on many methods. So during the time, so the code is changed. So initially the code was based on working stress method, then it was load factor method, and then it was now The code is based on limit state method. So we will see what is the design philosophy behind working stress method, load factor method, and limit state method. The other name for working stress method is modular ratio method or elastic method. And for load factor method, the other name is ultimate load method. Okay. So first, working stress method. Okay, what is working stress method? Okay, that will be the first method. We used it for the design of structures, and the main thing in working stress method is it considers only the elastic behavior of steel and concrete. Elastic behavior in the sense, once you apply the load, the body will get deformed. Once you remove the load from the body will regain its original position. There will not be any strain in the body, so that such type of condition is called as elastic behavior. So our assumption in working stress method is both steel and concrete will work together, and that will both will be elastic at all the stages. Okay, that is the main assumption in case of working stress method. So okay, based on this, they use a concept called modular ratios. Okay, what is modular ratio? A modular ratio will be a ratio of elastic modulus of steel to the elastic modulus of concrete. So, with the help of modular ratio, we can convert one quantity of a material to the other one. Like you can convert the quantity of concrete into steel or steel into concrete, vice versa. So why we are supposed to do is we have to make it into a uniform so that it will be easy for us to do some calculations. And the moment as well as quantity of reinforcement is mainly based on the modular ratio. So it is a important factor in working stress method. And permissible stress, so in case of working stress method we'll be using always this term. The term is called permissible stress. Permissible stress is calculated by specific factor of safety on material strength. So what we actually doing in working stress method is we will not be touching the loads. So whatever the load is going to act over the building, the same load will be using it, but instead the material strength, for the material strength will be applying factor of safety. So in the sense we'll be reducing the strength of the material, or we'll be utilizing only a specified limit of the material strength. So we'll be having some reserved strength always in the working strength method of designs. So if you see for concrete the factor of safety will be 3, and for the steel it will be 1.8. So the main advantage is the structure will be very safe, so that it will satisfy the serviceability condition always. But the disadvantage about the working stress method is it always leads to over reinforced structure, as we reduce the or will be limiting the usage of strength of the concrete. So in turn we are supposed to add more steel, so in that case the structure becomes over reinforced, so it may lead to sudden failures also. So definitely it will fails in safety condition. Okay, so but though it has some limitations, so still we will be using this method for the structures wherein we require no crack should be formed. So like water retaining structures, creation of formation of crack will be very will infuse a dangerous thing. So in that cases we'll be using this working stress method. Still people are using this method. Okay, next. Okay, next is load factor method. So this method is evolved after the working stress method. So it is a successor of working stress method. This method uses a load factor. So load factor, which means strength of horse's section at working load, is derived from ultimate load. So here is we will not be touching the strength of the material. So instead what we are doing is we'll be enhancing the load, or we'll be having some load factor with the working load, and we'll be converting that working load into ultimate load. So for that ultimate load we'll be doing the designs. So that is the main concept behind load factor method. So in that method, load factor is actually applied for the load and not for the material. And load factor is based on type of concrete used. In case of if you are going with the design mix, then you can have a load factor of value 1.5, or if you are going with some nominal mix, then you can have the factor as 1.65. So main concept behind load factor method is we will not be applying the load factor for the load factor for, we'll be applying it for the load and not for the material. That is the concept behind load factor method. And if you see, the advantage about load factor method is the failure of structure is due to tension failure of steel, not by the concrete. It satisfies the safety requirement. So as we know it, so we'll be having the ultimate load. For the ultimate load, we'll be going to provide the reinforcement. Once the load exceeds beyond certain limit on the structures, what happens is the steel will failure prior to the concrete, which is actually expected failure, so that we will be having sufficient warning before the failure of the structures. Okay, so it's sad, so that's why we used to call this as this satisfies the service safety requirements. Okay, disadvantage is the serviceability of the structure cannot be determined clearly. Why? Because is since we be designing the structure for ultimate load, predicting cracks will be a little bit tedious for us. So because of that, we cannot give some standard assurance for this serviceability case. Okay, so this is regarding the load factor method. Okay, next method is a limit state method. So limit state method, this is the successor of both working stress as well as load factor method, and this involves an statistical procedures. So based on that, we have having some approaches called probabilistic approach. Okay, it is based on probabilistic approach, and we'll be having two major parts in case of limit state method. One is limit state of serviceability. Okay, the one state is limit state of collapse, and the other is limit state of serviceability. So if you see, in case of working stress method, we applied the factor of safety for the material, and in case of load factor method, we applied the load factor for the load. But in case of limit state method, we'll be applying some partial safety factor for both the loads and the material. So that is a main concept. This is the factor is determined based on the statistical data. It mainly focuses on two concepts. One is material strength is reduced, and the load acting on the structure is converted to ultimate load for the design purposes. So what is the limit state of serviceability? The design structure need to satisfy the serviceability condition like cracking and deflection, and limit state of safety is the structure need to satisfy the conditions like buckling due to load and severe. So in case of limit state method, we are supposed to apply the partial safety factor. Okay, why we are saying this as partial safety factor in the sense, so we will not be applying the factors entirely for only one component. Here we will be splitting the partial, we are splitting the factor of safety, or we'll be applying the factor of safety for both components. So we used to call this as a partial safety factor. So we will be applying factor of safety partially for the load, partially for the material. So hence we used to term this as partial safety factor. Okay, so thank you for watching this video, and so this is regarding the basic design concepts of RC elements. In the future videos, we'll be seeing some more basics or some more advanced concepts relating with the RC elements. This is just the introductory video, only sufficient for this activity. Thank you very much.